So what is a triangle? Well, it's three segments joined by three, not just points, because I could put points in a straight line. Would that be a triangle? No. Yeah. Not quite. What is something that says that all three of them can't be on the same line? We do have, what was that? Non-collinear. They can't all be on the same line. If I put two on a line and one above it, I can make a triangle on it. So this has to be non-collinear, not on a straight line. Non-collinear. And let's just draw a triangle. The important thing about moving forward in this class is triangles won't just be, I won't say triangle 1. All these triangles that we're going to be dealing with in the class in the future are going to have 3 letters on them. So each one of these, what are going to be called vertices, or a vertex, will have a letter by it. When you name this triangle, so let's talk about its name. You're just going to put a small little triangle, and you're going to pick any order of those 3 letters you want to. So this could be triangle ABC. It could be, I don't need to underline it. It could be triangle BCA. It could be triangle, CAB, and any other variation. It's not like an angle. Remember, an angle has a specific part that's missing, so an angle, you have to put the vertex in the middle. For a triangle, any order works. Just pick the 3 letters and name it, and all of them will be the same triangle. Okay, the next thing we're going to talk about is a vertex / vertices. A triangle has 3 vertices. It has 3 vertices, and they're going to be basically the points that form this. So this would be, they have a vertex A, they have a vertex B, and a vertex C. So every one of these kind of points is a vertex. That's a vertex. We have another vertex down here. And C is also a vertex. And then it has 3 sides. The sides are going to be not a line, but it's going to be a line segment. So we're going to have line segment AB. We're going to have line segment, BC, and a line segment AC. It doesn't matter what order you put those in. So once again, this could be BA, CB, and AC. Doesn't matter as long as you're naming that segment. So we have 3 sides. I'm just going to name one of the sides. That's a side. It's got 3 sides, 3 vertices. It's also comprised of 3 angles. Angle A, angle B, and angle C. That's a triangle. It has 3 vertices, 3 sides, and because there's 3 vertices, it has 3 angles. Question on what a triangle is. Okay, now we have very specific ways to talk about triangles. We can classify triangles by the lengths of the sides and by the different angles that comprise it. So there's 3 different ways that we can classify sides of a triangle. The first thing is none of the sides are congruent. You have no side that's the same length. That is called a scalene triangle. Once again, that has nothing to do with angles. It's just 3 sides have to be different. Our next one is at least 2 sides are congruent. If I have 2 congruent sides, I must have some way to denote that they're congruent. The 2 easy ways to do this are put tick marks or put the same letter by it. So this could be AA, and maybe this last one is side length B to let us know that that one's a different length. Does anyone remember what it's called when you have 2 sides of a triangle being congruent? I know it's a shot in the dark. Some of us have heard this before, and it might have been so long ago that we're just like, nope, or it's on the tip of our tongue. Yeah. It is isosceles. Isosceles triangle. Isosceles triangle. Then we have one where all the sides are congruent. So that would look like if I had tick marks on all 3 of these, or I have the same letter on all 3 of them. AAA. And remember what that's called if all three sides are congruent. It's a very special triangle. Got that one too? It's called an equilateral triangle. If you look at your postulates and proofs and stuff sheet, you do not have these on there. These have to be memorized. So you have to know what a scaling triangle is, an isosceles triangle, and equilateral. It has to be memorized. These have to be memorized. You have nothing else to go back on. And I promise you it's on the test. These have to be memorized. All right, that's how you deal with the sides. Now, no matter what the side lengths are, they can start forming different angles. So the first kind of angle thing, now, this does not have to be a scalene triangle. This could be an isosceles. I know it looks like it's a scalene triangle where all three are different. It doesn't matter. You're just looking at the angles. In a triangle, you can have a triangle that has three acute angles. Now, we as mathematicians dug deep into the pocket of names to come up with this name. It's going to be awesome. If you have three acute angles, it is called an acute triangle. If you have nothing but acute angles, it's an acute triangle. All three of them are acute. Now, our next one. Don't get lost in the fact that it says one obtuse. That's the most obtuse angles you could have in a triangle. You could never have two. You could definitely never have three. The most obtuse angles you can have in a triangle is one. We're going to talk about this in a second, but the angles actually add up to 180, so you only can have one obtuse angle. If you have that one obtuse angle, you're going to be very surprised by this name. It's called an obtuse triangle. Then what if we have a right angle? You can only have one right angle in a triangle. If you have two of them, that means you have a rectangle, which is probably not a triangle. So one right angle creates what's called a right triangle. Remember that little box I put in there means 90 degrees. That's what makes it right. A right angle in that triangle, 90 degrees, equals a right triangle. Oof. Now we get to the worst name of them all. All angles are congruent. That means we put a little symbol right there. Anyone want to take a shot at the name of it has all equal triangles? Yeah. Congruent. I wish we did that.
Equilateral.
It actually is called, it becomes an equilateral triangle. But if you ever want to describe the angles, it's kind of like equilateral. It's called equiangular. Equiangular. And it's such a terrible name that's fun to say. Not really. Try it. Equiangular. Equiangular. It just makes your face do something funny. What typically happens, instead of calling it equiangular, we find out that these are actually equilateral. So if you have all three angles are congruent, that means all sides are also congruent. So we just skip equiangular and just call it equilateral. So you're going to see when we name these triangles, we're going to sometimes you can always use equilateral. If you want to say equiangular, you can just say equilateral. That covers all of it. Or you can call it equiangular. You are correct, but most of the time we just change the name to equilateral because we know it's going to be equilateral. Yeah?
So I can just put, on the test,
You can just put equilateral. Even though it doesn't match what we're doing next, you can just put equilateral. Just keep that in mind, okay? Yeah?
If we see all sides congruent, triangle.
If we see all sides are congruent, we put equilateral down. Okay, now when we name triangles, we don't just go off the sides and we don't just go off the angles. We actually use both bits of information. So that's what we're going to do through A through F. It says identify each triangle by its sides and its angle. So i.e., if we have an acute triangle that's also scalene, we call it an acute scalene triangle. We typically put the angles first. So we usually put the angles first. So if I look at the very first one, we're looking for, are all three of them acute? Is there one that's obtuse? Is there one that's right? Or are they all congruent? What do we notice about one or A and its angles? There's a right angle. So we know it's a right triangle first and foremost. So we're going to start with right because that works for the angles. Because of that 90 degree. Now, do you notice how it repeated a letter? A and A? That means it has two congruent sides. It has to be isosceles. So we start with right, and then we put isosceles after it. And then we just put that little triangle symbol after it so you don't have to write the word triangle. That's a right isosceles triangle. So we look at the angles first, then we look at the sides, and then we say what the name is. Our next one, we're looking for, does it have three acute? Does it have an obtuse? Does it have a right? Or are all the angles the same? Someone raise your hand and tell me what information we know about the angles for this one. Key? It's scalene. I think you're looking at sides. You jumped ahead of me. I'm just looking at angles. For angles, we're looking for, are they all three acute? Is there an obtuse? Is there a right? Or are they all the same? John Keaton? There's an obtuse. So what do we call this one? It's obtuse. And key, based upon the sides, what would the name be for sides? It would be a scalene. It's obtuse because we have one obtuse angle. It's scalene because I use three different letters, which means there's three different sides. So it's going to be a scalene, obtuse scalene triangle. Yeah, Griffin.
There always should be two words to describe it.
Always two words, except for if it's equiangular. Then we can just put the word equilateral. It suffices for both. All right, I'd like you to do C, D, E, and F. Either on your own or work with the guy next to you if you're not sure what's going on. Get the correct answer because I'm going to randomly pick on people after this. And are you telling me, because you said scalene, that all the sides are a different length? Cool. All right. So you're telling me there's an obtuse angle. And you said isosceles, so there must be two that are the same length. I would agree with that as well. All right, we're on E. Equilateral is fine on this one. You can just put equilateral. And you are 100% correct. If you were someone that wrote equiangular and equilateral, you're fine too. But equilateral suffices for all of it.
Scaling.
So you're saying it looks a lot like the one above it?
Yes.
In fact, it is the same one, so I think you are right that this is a right scalene triangle. All right, let's get to, we got to have this memorized, okay? On the test, there's a big part that has a whole bunch of triangles, and you have to pick what they are. Don't get all those wrong. It's an easy way to also sink your grade in such a small lesson when you want to have places to lose points on the proofs if you get those wrong. This is not the place to lose points. Now, let's get to the second big part. So words, big. Second big thing about triangles. The sum of angles equals 180 degrees. The sum of the measures of the angles of a triangle equal 180 degrees. I'm missing part of the slide here, but I'm just going to point. You have this in here. Basically, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. That's going to be very important to you because that means if you know two of the angles, you know that third angle. If I tell you have 30 degrees, 90 degrees, and you're missing an angle, you can just do 180 minus 90 minus 30, and you can get your missing one. Does that sound right, Marco?
Yes.
Okay. Glad you agree. Important stuff. That's important. I know it's at the bottom, and we're not really writing anything down, but that's important to know it equals 180 degrees. You need to know that for the test. We're going to skip the proof. I don't know if we're going to go back to it. We'll see at the end of the class. What's more important is the next thing we're talking about, and that is exterior and remote interior angles. When you extend the side of a triangle, so I'm looking at this triangle here. I'm specifically looking at extending this side here. You create a brand new angle formed by the triangle and this line. Not the 180-degree thing, but this angle 1 right here. That is called an exterior angle. This right here is called an exterior angle. That right there is an exterior angle. Once you pick your exterior angle, and you slowly put your phone back into your desk, once you pick your exterior angle, then you suddenly have what are called remote interior angles. Your remote interior angles are the two angles in the triangle that are not adjacent to that one. So this one doesn't count as remote interior. It's the two other ones. So if that's my exterior angle, that's going to make these two my remote interior. Remote interior are always two angles. And I'm going to stick to this picture. I'm going to add one more thing to this. I'm going to extend the other line. If I extend this other line, I can also label this as an exterior angle. This right here is an exterior angle. This angle right here is not an exterior angle. This is not an exterior angle. I'm just going to put not there. We struggle with that sometimes each year. It's just the ones formed by the side and the line. So that's an exterior angle, that's an exterior angle. Both of these are remote interior angles. Now, if I extended this bottom one, this 1 is my exterior, which makes 2 and 3 my remote interiors. If I extend this line this way, we have 1 being the exterior and 2 and 3 be my remote interior. Remote interior angles are always 2. That's important because on the test, I might just say name the remote interior angle /S. You have to know you have to name 2 things. So remote interior angles always come in pairs. Now, even more important than knowing what they are, we have to know this theorem. This theorem says your exterior angle equals the sum of your 2 remote interior angles. So, if you look here, this angle right here, measure of angle 1, is going to equal measure of angle 2 plus measure of angle 3. Important stuff. These are really easy points that you're going to lose on the test just because you're like, oh, it's the last lesson, I'm not going to pay attention. It's so juxtaposed to the rest of the stuff we do, we just forget it. It's easy stuff to practice. It's just you guys don't. That's historically what happens, that no one practices this. You get that wrong on the test, and all of a sudden you drop a grade just because you don't know how to do triangles. You're like, but I knew all the parallel line stuff. Not grade level, but a grade on the test. Like you should have got an A, and all of a sudden you get a B because you just refused to study the triangle stuff. Study the stuff. Know this theorem. All right, now how do we use this theorem? Well, let's use this theorem. Well, let's use a couple things on this one down here. In fact, let's skip that one and let's do example 2 first. Example 2 first, and then we'll go back up to the other one. Would you guys agree that 1 is an exterior angle? Okay. So if 1 is an exterior angle, would that be 80 and 18 be its remote interior angles? So what do we know about measure of angle 1 right now then?
It's equal to measure.
Not quite 100, but it'll be 98 because we just add the 2 remote interior angles. So measure of angle 1 just equals 80 plus the 18. So measure of angle 1 equals 98 degrees. And that's because this is an exterior angle. And with an exterior angle, I kind of picture them as being across. Those angles that are across from it are your remote interiors.
So it always has to be like 180 degrees.
It always, whoa. Say that again?
Like you always, like you said in the beginning of this lesson, you said that like it always has to be 180 degrees.
The inside of the triangle has to be on. Nothing with the remote or interior. But if we knew this was 80 and this was 18, I could find that missing angle as well. That's another way you could get there.
Yeah. So if you found that missing angle, that plus
Would be supplementary to that one. Yes. Now, that's good to know, but sometimes you have to know remote interior angles. Okay, so don't always do the workaround.
Okay.
There is a workaround, but there are times where you have to do remote interior angles. It's not on here, but it can show up on the test where you'd have to know it in order to do it. So our next one. I noticed 124 is an exterior angle, so 124, if I was writing an equation, 124 degrees is going to equal what? Notice how I set this up. 124 degrees would equal what based upon this stuff, Marco? 59, probably plus angle 2. I know what you're thinking because we're going to subtract that 59 from both sides. So we subtract 59 from both sides. We do some math yoga. Who can tell me what measure of angle 2 equals? I don't care if you use a calculator. Just give me an answer. Yeah. You're saying 65. I need a backup person. Does anyone else agree it's 65?
Yes.
Okay. Then I'll trust you guys. 65 degrees. Okay, now let's go to the more complex one. The more complex one, just solve it the way I'm solving it, okay? There's multiple ways to do this. I just want to make sure that we can do 2 different skills at once. So the first thing I'm going to do on this one is I'm going to highlight a triangle. I'm going to highlight this triangle and pretend like everything else does not exist. If I highlight this triangle, I know 2 of the angles, which must mean I can find that third angle. What do we know about the sum of all the interior angles of a triangle? Yeah. 8 equals 180. So when I'm looking at that triangle right there, what I'm picturing is, well, if I have 180, that must equal that 43 plus that 59 plus that x. That has to be true. My 3 angles have to add up to 180. Do you have to write that out every time? No. The other class asked, can I just take 180 and subtract those 2 angles and get that one? Cool. You might want to write something down just in case you made a mistake in your calculator. Like tell me you did 180 minus that, just in case you made a mistake in the answer key. But if you did this work, what is the measure of angle x? You think it's 78? Does anyone else think it's 78? Do the work. Don't just nod along. Nodding along is lazy. Are we good with 78? John Keaton is our check all. All right, cool. Now I want to point something else out. Look at y. Look at y real quick. In fact, I'm going to extend this line in blue. If I make everything else disappear, I'm going to do that because I have magic, you don't. If I make everything else disappear, what is y?
Or no.
Don't say the number. I mean, what would the name be? Yeah. That's an exterior angle, which means that it must have remote interior angles, right? So one quick way to do this is, and I never even had to find x, y must equal what 2 angles added together? Raise your hand and tell me y equals what 2 angles added together? Tito?
The 59 and 43.
The 59 and 43. So I'm going to go ahead and say that y is a remote interior angle, so I can say y equals just that 43 plus that 59. So y is going to equal what? 159 degrees? Did I get that right? 102. That sounds a little better. Are there other ways to find y? Yes. But I'd like us to at least try a remote interior angle. Find z. However you want to. I can see 2 different ways to do z. Find z. Yeah.
I don't understand how you got the y equals 43 plus 59.
We said that y is an exterior angle of that blue triangle. An exterior angle must equal its 2 remote interior angles. It's a nice little shortcut to get to that one if you know these 2. If you get z, raise your hand. Shout it out, and then we'll check. Yeah, what'd you come up with? 29. Keep solving. I want to make sure it's correct. Give me a thumbs up if you think that's right when you get it, and then you can put it down. Okay, I got a couple people giving me thumbs up. You can put it down. Looking good. All right, can someone that didn't give me the answer tell me how you can come up with 29? Yeah, Key.
I did 1 and 2, since I knew y was 1 and 2, I did 1 and 2 plus 49, which got 151. Then I subtracted 151.
Okay, so I'm just gonna write an equation of what you did. So you did, if I did 49 plus 102 plus z, that would have to equal 180 degrees. And in short, that's what you did because you just subtracted it. Okay, that's perfect. Can anyone think of another way I could get z? It's a harder way. I'm just gonna point this out. You don't have to do it this way. But what I saw is a red triangle where x was our exterior angle. And we knew what x is. X had to be 78. So 78 had to equal 49 plus z, which would also give you your z. That's where you can do a nice exterior angle. I know exterior angles aren't exciting, and you don't always have to use them, so sometimes you do that workaround. You just find that. I highly suggest you try to use remote interior angles. If you don't practice it, you're going to get the problems where you have to use it, and you're going to be kind of stuck because you don't know how to use it. So make sure you at least take some seconds to practice it. All right, that's really all I have for you. Are there any questions for me? I try to give you some time to work. We should have multiple minutes to work. Yeah. Okay. For D or number 4 on the homework, you're going to have to write an equation. You're not going to have a number for an answer. Oh, and now for the parade of bathrooms? I saw your hand first. You can go. And then you're going to go when he comes back.